Hi friend, myself Jitendra Kumar. I am taking Power Electronics of 5th semester Electrical Engineering student. As per the previous lectures, we are discussing the various things which are related with the silicon control rectifier or the components which are associated with the power electronics and applications of the power electronics and how we have to just make these devices for the environment. Now, in these lectures, we are discussing about the various different parameters like the ratings of the SCR, protection related to the SCR against the overcurrent, overvoltage, change in voltage with respect to time at a higher rate, or change in current with respect to time. That will be discussed over here. Then there will be the thermal protection and the snubber circuit, which are associated with the SCR to give up the application as a smoothly operation. We are just focusing on these things in this lecture. First thing, the protection of a device is an important aspect for its reliable and efficient operation. Trigger control rectifiers are a very delicate semiconductor device, so we have to use it in its specified ratings to get desired output. SCR may face different types of threats during its operation due to overvoltages, overcurrent, etc. There are different types of thyristor protection schemes available for satisfactory operation of the device, like overvoltage protection, overcurrent protection, high dV by dt protection, high dI by dt protection, and the last one is the thermal protection. First one, we will start about the over voltage protection. It is the most important protection scheme with respect to others, as thyristors are very sensitive to over voltage. There is a maximum limit. So maximum time thyristor failures happen due to over voltage transients that will be appear on the device. A thyristor may be subject to internal or external overvoltages. So be careful about this thing. That the overvoltage protection is the most important parameter while we have to look over the machine. Internal overvoltages after commutation of a thyristor. Reverse recovery current decays abruptly with high dI by dt, which causes a high reverse voltage as V equal to LDI by dt. So if di by dt is high, then V will be large. That can exceed the rated breakover voltage and the device may be damaged. For the external overvoltages, these are caused due to various reasons in the supply line like lightning, surge conditions, abnormal voltage spike, etc. Operation like increase in leakage current, permanent breakdown of junctions, unwanted turn on of the devices, etc. So we have to compress the over voltages. The protective device for this one is the effect of over voltages can be minimized by using non-linear resistors called voltage clamping devices like metal oxide resistors. At the time of normal operation, it offers high impedance and acts as it is not possible in the circuit. But when the voltage exceeds the rated voltage within a as a low impedance path to protect the SCR. Next is the overcurrent protection. Overcurrent mainly occurs due to different types of faults in the circuit. Due to overcurrent, I square R loss will increase and high generation of heat may take place that can exceed the permissible limit and burn the device. Though the protective measures we apply over the overcurrent protection are SCR can be protected from overcurrent by using circuit breakers and fast acting current limiting fuses. CBs are used for protection of SCR because against continuous overloads or overcurrent of long duration as a circuit breaker has long tripping time. But fast acting fuses is used for protecting SCR against high surge current of very short duration. Net protection with a high voltage dV by dt protection when a thyristor is in forward polarity. We state that only J2 junction is reverse biased, which acts as a capacitor having constant capacitance value Ca. Junction just called the junction capacitance. As we know that current through capacitor follows and leakage current through the junction J2, which is nothing but the leakage current through the device will increase with the increasing dVA by dt. That is rate of change of applied voltage across the thyristor. This current can turn on the device even when the gate signal is absent. This is called dV by dt triggering and must be avoided, which can be achieved by using cinema circuits in parallel with the device. Next will be the protective measures. Nervous circuit consists of a capacitor connected in series with a resistor which is applied parallel with the resistor. When S is closed, then voltage Vs is applied across the device as well as Cs suddenly. At first, snubber circuit behaves like a short circuit, therefore voltage across the resistor is zero. Gradually, voltage across Cs builds up at a slow rate. So dV by dt across the resistor will stay in allowable range. Before turning on off resistor Cs is fully charged and after turning on-off thyristor, it differs through the SCR. This discharging current can be limited with the help of thyristor connected in series with the capacitor Cs to keep the value of current and rate of change of current in a safe limit. Next will be the high dI by dt protection. When a thyristor is turned on by gate pulse, then charge carrier is spread through its junction rapidly. But if the rate of rise of anode current, that is di by dt, is greater than the spreading of charge carriers, then localized heat generation will take place, which is known as local hotspot. This may damage the thyristor. Protective measure for the above previous considered. To avoid local hot spots, we use an inductor in series with the device as it protects high rate of change of current through it. Next will be the high temperature protection. With the increase in the temperature of the junction, insulation may get failed. So we have to take measures to limit the temperature rise. Protective measures, we can achieve this by mounting the thermistor on heat sink, which is mainly made by high thermal conductivity metals like aluminum, copper, etc. Mainly aluminum is used due to its lead mounting, stud mounting, bolt down mounting, and brush hollow mounting, press fit mounting, and press backpack mounting, etc. Next will be the gate protection of thyristor. Like a thyristor, gate circuits should also be protected from over voltages and overcurrent. Over voltages in the gate circuit can cause false triggering and overcurrent cause high junction temperature. The protective measures are where over voltages thyristor protect state is achieved by using a Zener diode, and a thyristor can be used to protect the gate circuit from overcurrent. Noise in the gate circuit can also be cause false triggering, which can be avoided by using a resistor and a capacitor in parallel. A diode can be connected in series or in parallel with the operating frequency, protected from high reverse voltages. Next will be the overloaded protection of lead mounting. In such mounting technique, housing of SCR itself is used as heat radiator. Hence, no need of additional heat sink arrangement. Hence, this technique of thyristor protection is usually used for low current application, normally less than 1 ampere. Stud mounting as the anode of thyristor is in the form of threaded study which is screwed to a melting heat sink block. Next is the bolt down mounting. Here the device is connected to the heat sink with the help of nut bolt mechanism. It is mainly used in small and medium rating cycles. Press fit mounting this kind of mounting is obtained by inserting the whole SCR into the metallic block. It is used in high rating SCR press back mounting. This kind of mounting for thyristor protection is obtained by sandwiching the thyristor between the anode and cathode. This kind of mounting protection is obtained by the sandwiching the thyristor between two heat sinks with the help of the clamps. It is used for very high rating circuits. Now these are the different types of protection we are discussing over the SCR where each and every protection is the most important parameter while we have to just make it for the specific high voltage and high current application. Now this is the end of the lecture. Thank you.